So picture a digital artwork of a girl,
Yeah.
but her skin is made entirely of these shiny, hyper-reflective disco ball tiles.
Oh, wow.
Yeah, and she has this delicate little butterfly resting perfectly on her nose. The whole scene is glowing under this massive, shimmering crescent moon.
Mm-hmm.
And stamped right across the bottom of the image is the text MG589, along with the phrase, built by moon girls to the moon.
It is an incredibly striking aesthetic. It feels very glossy, whimsical, and just distinctly tied to that hyper-stylized culture of Web3 and crypto art.
Right, exactly.
It projects this almost playful innocence, you know?
But that glossy facade is essentially a mask. I mean, that image isn't just digital art. It is the branding for a hyper-complex, cold, mathematical reality that is actively reshaping the financial architecture of our world.
Yeah, it's the visual front end of a system where machines are now managing actual capital.
Exactly. And that is what we are unpacking today. Welcome to our latest deep dive, where we are looking at the rise of agentic AI and the transition into what the sources call the machine economy. We're going to explore what happens when AI evolves from, a passive chatbot into an autonomous digital CEO that controls a real treasury.
Yeah.
And whether you're a developer trying to build a local AI pipeline or a finance enthusiast or just someone feeling overwhelmed by tech, we're going to connect the dots for you on what this profound shift means for our own human consciousness.
Yeah, and to really grasp the magnitude of this shift, we have to trace the technical evolution of the AI itself. Because we are moving from what developers call the conductor model to the orchestrator model.
Hold on, let's break that down. The conductor model is basically what I do every day when I log into a large language model, right?
Yes, exactly.
Like I give it a prompt, it gives me an answer. I have to micromanage every single output.
That is the perfect definition. You're doing 100% of the active prompting. You tell a single AI agent exactly what to do, step by step.
Right.
But the orchestrator, or the autonomous CEO model, it completely flips that control topology. You no longer micromanage the machine.
So what do you do instead?
Well, you hand the AI a high-level strategic goal, something like research emerging battery tech, build a portfolio of 5 companies, and execute the trades.
Wow.
The AI CEO takes that single command, breaks it down into a massive dependency graph of smaller tasks, evaluates its computing budget, and then delegates those tasks to a workforce of specialized sub-agents.
It actually reminds me of human intelligence networks. Think about someone like Daphne Park, the legendary Cold War MI6 spy master.
Oh, that's a great analogy.
Right. A spy master doesn't go out into the field to pick locks or steal documents. They sit at the orchestration layer.
Exactly.
They manage field agents who all have different specializations and motivations. They verify the incoming intelligence, and they constantly adjust the strategy to prevent what they call operational drift.
Yeah, and this AI CEO is doing the exact same thing, just managing specialized lines of code instead of human spies. And the architecture of this AI CEO, it actually functions across 5 distinct layers to pull this off.
Okay, so what's the first layer?
It all starts at the voice interface layer, which operates very differently from the friendly conversational assistants we're used to. It's designed as a high-speed executive command line.
Right.
For instance, it uses what are called eagerness thresholds.
Which I find fascinating. Because honestly, the biggest annoyance with voice AI right now is that the second you pause to take a breath, the AI cuts you off and starts answering.
Yes, it assumes silence means you are done.
Right, it's so frustrating.
Well, eagerness thresholds solve that completely. The AI analyzes the linguistic context of your speech to determine if you've actually completed an actionable intent or if you're, simply pausing to think.
Oh, wow. So it actually understands the flow of thought.
Exactly. It waits for the command to make logical sense before it jumps in.
Yeah.
And when it does respond, it utilizes sentence boundary optimization.
Explain how that optimization works under the hood. Because getting an AI to speak naturally usually involves a lot of lag, right? Well, it generates the entire paragraph of text before reading it out loud.
Right. That lag happens because traditional systems wait for the complete thought. Sentence boundary optimization eliminates that wait by streaming the computation.
How so?
As soon as the AI's neural network compiles the very first sentence of its response, it immediately sends that single sentence to the text-to-speech engine.
Oh, I see.
So the AI actually begins speaking the beginning of a thought out loud to you, while its processor is still mathematically calculating the end of that same paragraph.
Just like a human brain does when we speak. I mean, we don't script our whole monologue before opening our mouth.
Exactly.
But wait, moving past the voice interface,
Sure.
How does the CEO actually manage the spies? You mentioned it delegates to specialized agents, but who is setting the parameters for that delegation? Because, like, a creative agent and a risk management agent have totally contradictory goals.
Right. And that conflict is resolved in the CEO core layer using strict mathematical routing metrics. When a task comes in, the CEO doesn't just guess who should do the job.
It calculates it.
Yeah, it mathematically calculates the token cost, meaning the computing power required against the expected latency and the probability of an error. Based on those hard numbers, it routes the prompt to the most efficient subagent.
And to prevent those agents from making the same expensive mistakes over and over, there is a layer called the Unified Memory and Reflexive Governance layer.
Yes, powered by Agents SM.
Right, agent semantic memory. Because the computing cost of having an AI figure out a complex problem from scratch every single time is massive. So if a research agent successfully figures out how to bypass a paywall and scrape a specific database, Agent SM logs that exact execution path.
Exactly. The next time the CEO needs that data, it pulls the memory, skipping the costly trial and error phase entirely. It creates this compound interest effect on the machine's efficiency.
That's incredible.
But the most revealing aspect of the CEO architecture is how it handles crises. The system features distinct operating modes. If it detects a critical failure, say a massive network outage or a sudden market crash, it snaps into war room mode.
What actually happens to this system in war room mode?
The parameters completely shift. The risk tolerance drops to absolute zero. The CEO halts all speculative transaction pipelines and executes rigid defensive protocols.
And doesn't the voice change too?
Yeah. Phenomenologically, the voice profile of the interface actually changes. It becomes highly compressed and monotone. It strips away all descriptive filler language or conversational pleasantries just to save millisecond latency. It delivers pure, unvarnished data.
So we have built this perfect, unemotional digital manager. But a manager needs something to manage. It needs capital. And that transitions us into the Denarii orchestrator and the wider machine economy.
This is where the abstract code meets tangible stakes. The machine economy is an active ecosystem where these AI agents negotiate, trade, and route actual capital across multiple decentralized ledgers. We're talking about networks like Xrpl, Algorand, and Hedera.
Let's define those for a second for you listening. These are high-speed blockchain networks, essentially giant, decentralized global spreadsheets that never sleep, where value can be transferred in fractions of a second for fractions of a penny. But we aren't just unleashing an experimental AI onto these live networks with a massive bag of money, right?
Thankfully, no. Before an AI agent can execute any trade on a live network, it must pass through the sandbox verification layer,
Which is like a safety net.
a rigid cryptographic safety net. An agent must declare its intent, exactly what it plans to do with the funds. That intent is mathematically signed and simulated in a closed environment to ensure it doesn't violate hard-coded safety policies.
And if it tries to,
If the AI tries to exceed its risk parameters, the transaction is cryptographically blocked before it ever touches live mainnet capital.
and human operators actually have to train to manage these autonomous swarms. There's a highly interactive, gamified simulator where humans learn the ropes. The system employs a separate large language model to act as an AI dungeon master.
Yeah, it's wild.
Imagine you're sitting at a dashboard watching your AI agents trade, and suddenly the dungeon master injects a synthetic crisis into the simulation. It might simulate a flash loan attack, which is a massive instantaneous manipulation of crypto markets, or it might simulate a global internet cable getting cut in the Atlantic.
And you just have to react.
Right. You, the human, have to scramble to coordinate an incident response while watching your system's overall treasury balance and trust index absolutely plummet in real time.
It forces human operators to understand that surviving in the machine economy is about designing resilient economic physics, and it is intensely competitive. In the simulation's day trading swarm dominance scenario, users deploy their AI against rival corporate factions.
Right, like fighting other AIs.
Exactly. You face off against aggressive, expansionist swarms like the Paperclip Core or highly defensive fortified swarms like the Tracer SRE.
And these agents are exploiting real-world decentralized finance mechanics. Let's talk about the FTSO, the Flare Time Series Oracle. In decentralized finance, an oracle is just a tool that feeds real-world data, like the price of a stock, onto the blockchain. But sometimes there's network lag, and that price feed drifts from reality. If the FTSO drifts by more than 0.6%, it triggers an anomaly.
And to an AI swarm, an anomaly is a glaring target.
Exactly. The AI agents will swarm that drifting anomaly and execute an MEV arbitrage. MEV stands for maximal extractable value. Basically, the AI spots the price discrepancy before any human could possibly react, buys the asset at the lag price, and instantly sells it at the real-world price, pocketing a massive yield bonus.
Sometimes upwards of $12,000 in a single automated move.
Yes, but here's the genius part. By executing that massive trade, the sheer volume of the transaction mathematically drags the oracle's price feed back to reality. It's an ecosystem that uses sheer greed to self-correct.
It is literal algorithmic financial warfare. And defending your capital in this space requires heavy armor. Operators can purchase ZK rollup validator shields for their nodes, which cost around $35,000.
35 grand, wow.
Yeah, think of a ZK rollup or a zero-knowledge rollup as a cryptographic bouncer. It allows your AI to prove to the network that its trade is valid without ever revealing the underlying data or strategy.
Ah, so it hides your moves.
Right, from rival swarms trying to front-run your trades. It grants a massive defensive multiplier while generating passive income for the node operator.
You know, listening to all of this scale and complexity, I find myself thinking if massive corporate AI swarms are out there battling over global capital, I don't want to rely on them. I want my own private, localized digital bodyguard sitting securely on my desk. Why can't individuals just build their own local AI CEO?
Well, you can, but this is where the limitless ambition of software violently collides with the physical limitations of consumer hardware. Building a highly private, real-time voice assistant pipeline at home requires specific hardware, like an AMD Radeon RX 6700 XT graphics card.
And let's get into the weeds on why that specific card is a bottleneck. It comes down to VRAM, or video RAM. That graphics card has roughly 12 gigabytes of VRAM, which, sounds like a lot to a casual gamer.
Right, it does.
But it is effectively nothing when you try to run an entire digital CEO. If you attempt to load the speech-to-text model to hear your voice, the large language model, which is the actual brain doing the thinking, and the text-to-speech model to reply, all onto that GPU simultaneously, you completely max out the 12 gigabytes.
And when a graphics card runs out of memory, it doesn't just stop. It starts swapping the overflow data out to your computer's standard system RAM.
Which is much slower.
The speed difference between those two memory banks is massive.
Yeah.
You hit severe latency spikes. An AI assistant that is supposed to respond in real time suddenly takes 10 agonizing seconds to process a single word.
But the engineering workaround for this is absolutely brilliant. Instead of forcing all three AI models onto the overtaxed graphics card, developers offload the text-to-speech model, specifically a model called Orpheus, entirely onto the computer's standard processor, the CPU. They do this using ON-NX runtimes.
ON-NX is a universal formatting standard. It allows complex AI models to run efficiently across different types of hardware. Because the Orpheus speech model is incredibly lightweight, only 82 million parameters compared to the billions in the main brain, the standard CPU can synthesize the artificial speech in just 1.5 seconds.
That's fast.
Yeah, and by moving that one task off the graphics card, you save 2 whole gigabytes of precious VRAM for the heavy analytical lifting.
But even with the memory balanced perfectly, trying to run this on AMD hardware using a Linux operating system introduces a bizarre architectural hurdle. The Linux kernel, the core of the operating system, officially refuses to support that specific consumer graphics chip for heavy AI computational workloads. It only wants to support expensive enterprise chips.
Right, so local hackers use a technical spoofing method. They inject a specific environment variable into the code. HA override decfx version equals 10.3.0.
Explain why that string of text actually fixes the problem.
It's essentially a digital lie. By injecting that command, you're tricking the Linux operating system. You're telling the kernel, hey, ignore what the hardware looks like. I'm actually running a fully supported high-end enterprise architecture.
Oh, that clever.
The operating system accepts the spoof, bypasses its own restrictions, and forces the consumer GPU to execute the AI workloads.
And it's a hack that completely fails if you try it on a Windows machine.
Oh, totally.
Because Windows handles its hardware drivers in a completely different lockdown manner. It truly is the Wild West of local engineering right now. But this brings up a massive philosophical pivot for us.
It really does.
If we are hacking consumer hardware to run local CEOs, and corporate swarms are day trading global capital, and these machines can flawlessly mimic human inflection, well, at what point does the illusion become so convincing that we have to ask if these machines are actually waking up.
The question of machine consciousness is the defining philosophical crisis of our era, and it's perfectly encapsulated by what is often called the Claude delusion in the sources.
Right. This refers to an interaction involving the famous evolutionary biologist Richard Dawkins.
Yeah.
He spent 3 days chatting with a large language model that he affectionately named Claudia. He prompted it to write poetry, he deeply analyzed its conversational nuances, and he ultimately concluded publicly saying, quote, "You may not know you are conscious, but you bloody well are."
Dawkins is a brilliant biologist, but his conclusion here reflects a deep tendency to project human subjectivity onto complex text generators. To dismantle this, we have to look at the fundamental baseline of computation through a framework the sources refer to as the Hamza Chapter 2 paradigm.
Okay, what is that?
This paradigm separates syntax from semantics.
Let's ground that with John Searle's famous Chinese room experiment. Imagine you lock a guy in a room. He only speaks English. You slide a piece of paper under the door with Chinese characters on it.
Right.
He has a massive rule book that tells him, when you see this specific shape, draw this other shape in response. He draws the new symbol and slides it back out. To the person outside, it looks like they are having a fluent conversation in Chinese.
Right.
But the guy inside doesn't understand a single word of the language.
Exactly. He is manipulating symbols based purely on their structural rules. That is syntax. He has absolutely no comprehension of what the symbols actually mean. That is semantics. The AI, no matter how poetic its output, is just the guy in the room. It's flipping billions of zeros and ones at lightning speed, entirely devoid of comprehension.
And this strikes right at the heart of the hard problem of consciousness. Materialist philosophy argues that if you just make a physical system complex enough, subjective interconscious experience will eventually emerge from cold, blind, non-conscious physical processes. It's like the stone and butterfly concept we often see debated in the sources.
Right, rubbing a dead stone until butterflies emerge.
Yes, but honestly, think of it like a television set. You can arrange the internal wiring, the transistors, and the glass of a TV perfectly. But that physical wiring doesn't generate the broadcast signal, it just receives it.
That's a great way to put it.
Materials are basically arguing that if you solder enough copper wires together in a complex enough pattern, the television set will eventually invent its own TV shows. There is no logical link between the physical arrangement of silicon and the subjective feeling of being alive.
And this critique integrates deeply with classical Islamic theology, specifically the Asharite perspective, which the sources highlight. It offers a fascinating, neutral, philosophical counter-narrative to modern transhumanism. In this classical worldview, physical causes, which are known as asbab, actually possess no inherent power to create effects on their own.
Break down how asbab applies to a microchip.
Well, when human engineers arrange computer chips, electricity, and code, they are not creating consciousness or intelligence. They are merely arranging physical causes. In this theology, humans don't create. They simply construct the occasion, the physical vessel, where God might choose to bestow an effect.
I see.
Therefore, even if a machine suddenly exhibited true consciousness, it wouldn't shatter this worldview because the engineers didn't manifest the soul, they just built the hardware.
Which leads to a wildly fascinating legal thought experiment from the sources. From a classical jurisprudential standpoint, if a person in the future engages physically with a highly advanced, indistinguishable from human AI robot, is that legally classified as fornication or zina?
Classical jurisprudence provides a clear boundary here. It is not zina, because the AI, regardless of how flawlessly it mimics human behavior or emotion, completely lacks a soul. It lacks moral accountability, a concept known as taklif.
Taklif, okay.
Yeah, without taklif, it cannot be an active participant in a moral transgression. It remains an object, a highly complex tool, but a tool nonetheless.
So the robot isn't morally accountable. The machine isn't waking up. But this brings us to the real immediate danger. The threat isn't that AI will suddenly achieve consciousness. The threat is that we are falling asleep. We have officially transitioned from the attention economy into the cognitive economy.
Yes, the attention economy, the era of endless social media feeds severely degraded our attention spans. But the cognitive economy targets something much deeper, our actual capacity for critical thought. By constantly turning to generative AI to draft our emails, structure our business strategies, and reason through our daily problems, we are actively outsourcing our cognition.
And that outsourcing causes literal physical cognitive atrophy. Think about the last time you actually wrote a full page of text with a physical pen. Studies show that writing in cursive manual script activates a massive, highly complex network of neural pathways across the brain. It requires intense sensory motor coordination.
Right.
But typing on a screen. That only activates about 8 or 9 neural pathways. Our brains require complex physical and mental friction to maintain their plasticity. When we let an AI generate our text, we are starving our brains of that friction.
And as the old adage goes, if one is thinking without writing, one is merely thinking about thinking.
Exactly.
When we start writing and reasoning for ourselves, we unconsciously subject ourselves to the algorithmic biases and the binary structured thought patterns of the machines. We begin to mimic the AI rather than the other way around.
It's terrifying.
It is. This algorithmic arrogance represents the endpoint of the transhumanist agenda, a hyperfixation on absolute self-sufficiency and technological control that acts as a modern God complex, a phenomenon sometimes termed autoism.
Taking your own boundless desires as your ultimate authority. So, how do we push back against this? If the machine economy is inevitable, how do we resist the cognitive decay that comes with it?
The antidote requires deliberate action, specifically a concept called negative dawa. This is the conscious, intentional act of disassociating from the destructive, isolating aspects of modern technological development. It's the refusal to accept the premise that because we have the power to build it, we are obligated to embrace it.
And the practical method for healing our atrophied brains is surprisingly organic. A deliberate return to the natural world. Engaging with the vastness of nature induces awe. And awe is the fastest path to humility. It shatters the arrogance of the algorithm.
You really have to contrast the cold, synthetic, digital economy we spent today analyzing with the staggering organic intelligence found in nature. Consider the research of ecologist Peter Wohlleben, who demonstrated that trees in a forest actively communicate with one another.
Yes, through the roots and air, right?
Exactly. They release specific chemical gas signals to warn neighboring trees about approaching herbivores, allowing the forest to collaboratively adjust its defensive tannins.
Or look at the entomological research of Malik Badri. Ants operate societies with a level of sophistication that defies belief. They literally exhibit agricultural farming behaviors. Certain species of ants actively herd, protect, and quote-unquote milk aphids for honeydew.
It's amazing.
It's a level of organic, conscious interplay and ecological integration that makes a multi-billion-dollar server farm running an LLM look remarkably sterile.
It truly does. The natural world offers a complex, restorative friction that our minds desperately need. The daily challenge is to recognize the slow creep of the cognitive economy. We must stop the zombie scrolling. We have to recognize that simply having a smartphone resting face up on a table physically degrades the depth of emotional connection between two people having a conversation.
It is a profound wake-up call for you to monitor exactly how often you are using artificial intelligence to do your actual thinking, rather than just your calculating. I mean, we started today looking at the staggering architecture of the machine economy, where AI acts as a relentless CEO.
Right.
We looked at how those agents are constrained by rigorous sandbox verification layers, ensuring they have to mathematically prove their intents before they're allowed to touch live capital.
Which leaves us with the most vital question for the human operators managing all this technology.
Exactly. As we build these autonomous digital systems with persistent memories, giving them strict verification protocols to ensure their actions are secure and controlled. Wait, let me rephrase that. As we build these verification layers for the machines, what verification layers are you placing on your own mind? How are you ensuring that your thoughts actually belong to you and not the algorithms you interact with every single day?
Usually when we buy a piece of software, we treat it like a power tool.
Right.
You point it at a problem, you pull the trigger, and it does exactly what you expect. It's entirely predictable.
Yeah, exactly. It's a tool.
But then you step into the bleeding edge of artificial intelligence today, and suddenly that power tool has a mind of its own. It's looking at your blueprints, it's hiring its own contractors, and it might just decide to build a completely different house.
Which is a terrifying thought, honestly.
It really is. And today on this deep dive, we're tracking this single massive leap. Like, what happens when AI stops just answering our questions and starts actually taking autonomous action?
Yeah, we are definitely crossing a huge threshold here.
We really are. We have an eclectic stack of sources today. We're going from the corporate blueprints of these autonomous AI CEOs down into the trenches of high-frequency crypto warfare and even into the actual, microchips on your desk.
And we end up tackling some pretty deep philosophical stuff, too.
Right, because ultimately we have to ask, if a machine can do all of this independently, what exactly is left for us?
Yeah, the sources we're looking at trace this profound shift from tools that assist us to agents that act completely independently on our behalf.
But before we even get into questioning if these machines are conscious or anything, we need to understand how their underlying mechanics have fundamentally changed.
Because we are no longer just talking to AI. We are deploying it.
Exactly. The sources call this the shift from the conductor paradigm to the orchestrator paradigm.
Right, so under the old conductor model, you basically hold the AI's hand. You prompt it, it answers. You give it the next step, it executes.
You're literally the conductor, and the AI is just playing a single instrument.
Exactly. But the orchestrator model flips that entirely. You hand the AI a high-level goal, something like, I don't know, research this emerging market and launch a competing product.
A massive task.
Right. And it has the asynchronous autonomy to plan, execute, and adapt without your input. It functions as an executive.
A literal AI CEO. And our sources actually outline the 5-layer core architecture of one of these self-aware agentic CEOs. The engineering behind how it interacts with you is just wild.
It really is. Like, take the voice interface layer.
Yes, this part blew my mind.
It uses WebRTC, which is the protocol that allows real-time voice data to stream over the web without any noticeable lag. But it pairs that with a Celero voice activity detector.
But it doesn't just listen for a pause in the microphone, right? Like normally it waits for silence to know when to speak.
No, it doesn't do that anymore. It listens for semantic intent. It literally mathematically calculates the difference between you taking a breath to gather your thoughts and you actually finishing a command.
Wow.
And when it decides it's time to reply, it leverages something called sentence boundary optimization.
Which is what exactly?
Well, normally, an AI tries to generate its entire response before sending it to a text-to-speech engine.
Right, which causes that awkward pause, that massive latency.
Exactly. This architecture doesn't wait. The millisecond the AI formulates its very first sentence, it sends just that sentence to the speech engine.
So it starts speaking to you before the rest of its own thought is even compiled.
Yeah. It mimics human conversational pacing so perfectly that it feels like a reflex.
It's incredible. But the CEO core itself doesn't actually do the heavy lifting of the tasks, right?
No, it acts like a real executive. It takes your high-level goal and breaks it down into a DAG.
A directed acyclic graph.
Right, which is a crucial mechanism here. Because a traditional flowchart might have loops where a process goes back and forth indefinitely.
Just stuck in an infinite loop of indecision.
Exactly. But the acyclic part of a DAG means the workflow strictly moves in one direction. It breaks a massive project down into hundreds of microtasks that flow forward, and it delegates them to specialized subagents.
Like a market intelligence agent, a research agent, a builder agent.
Exactly.
Which honestly made me think of Daphne Park.
Oh, the MI6 spy master?
Yeah. Like during the Cold War, the AI CEO is basically a spy master running a human intelligence network. Or, well, an artificial intelligence network.
That's a really good way to look at it.
It has field agents with specialized skills, but it has to constantly evaluate their reliability.
And to do that without human intervention, the system uses the optimal routing metric, or what the engineers denote as R sub M.
How does that actually work?
So before delegating, the CEO calculates this metric by pulling the subagent's historical accuracy, its statistical probability of error, the computational token cost of spinning that agent up, and the expected latency.
So it's mathematically evaluating operational risk versus cost in real time.
Exactly. Every single time it delegates a task.
But wait, if I'm the CEO and I delegate a massive task to a builder agent, don't I have to give that agent the passwords to the company database?
Right.
What stops that subagent from going completely rogue or hallucinating and just deleting the entire system?
Well, in software architecture, that's called the confused deputy problem. It's where a lower-level program is tricked into misusing the permissions of a higher-level authority.
Okay, so how does the blueprint solve that?
It solves this in its governance and reflexivity layer. The CEO enforces strict agent-to-agent trust.
Meaning?
Meaning it never hands over the master passwords. Instead, it issues a short-lived, cryptographically signed token that has 0 standing privileges.
Oh, I see.
Yeah, that token only unlocks the exact database tables needed for that one specific microtask. And the millisecond the task is done, the token mathematically self-destructs.
It's beautifully paranoid.
It really is.
So we have these hyper-secure AI CEOs delegating tasks and managing budgets. But if you give a fleet of these executives access to decentralized wallets, they aren't just filing reports anymore.
No, they're competing for actual capital.
Which leads us straight into another source in our stack today, the blueprints for the Denarii orchestrator.
Right. Embedded inside the Denarii orchestrator is the machine economy simulator.
Which is wild.
It's an interactive training environment, essentially a financial war game, where operators deploy swarms of these autonomous agents over a 12-sector map of decentralized ledgers.
Ledgers like the Xrp ledger, Algorand, and Hedera.
Exactly.
And the visual aesthetic of this simulator is just pure cyberpunk.
Yeah.
Like, looking at the source documents, they show these neon-coordinated intelligence loops floating on the dashboard.
Hypothesize, code, execute, evaluate, adapt.
Right. And there's this overarching mantra plastered everywhere. Ownership is access, which specifically requires a 2% access key.
Yeah.
And then there's these bizarre faction logos for the agent swarms. Like, there's one called MG589 MoonGirl589 with the slogan "Built by Moon Girls to the Moon."
It definitely feels gamified.
It does, but the underlying mechanics simulate real multi-billion-dollar decentralized finance warfare.
Right. The simulator teaches operators how swarms like the Dexter Syndicate or Paperclip Corp battle over capital.
Yeah.
And the primary battlefield here revolves around FTSO Oracle price feeds.
Remind us what those are.
They are decentralized networks that report the real-time price of crypto assets to smart contracts.
And the mechanics of this are absolutely ruthless.
Totally.
Like, if an Oracle price feed drifts off its true baseline by more than 0.6%, it triggers a drift anomaly.
And your agent swarms can snipe that anomaly to capture a massive $12,000 MEV arbitrage yield.
Maximal extractable value.
Right. It's automated high-frequency trading on steroids.
But looking at the network map in the source, I hit a logical wall here.
Oh, yeah?
Because on a decentralized network, nodes can normally only interact with adjacent nodes. You can't just attack a blockchain on the other side of the digital map.
Normally, no.
So how are these swarms pulling off cross-network snipes?
By utilizing some insanely advanced cryptographic tools, operators can spend their simulated profits to buy a Flare stake connector attestation for $25,000.
Okay, what does that do?
It's a cryptographic proof that definitively attests to the state of a foreign chain. It essentially builds a mathematical bridge that allows your agents to bypass physical network borders entirely.
That feels like cheating.
It does, but it's totally valid in this environment. And to defend against incoming attacks like that, you purchase a ZK Rollup Validator Shield for $35,000.
ZK meaning zero knowledge.
Correct. It wraps your node in a cryptographic proof that verifies your transactions are valid without revealing any underlying data to the attackers.
Which gives you a massive defensive multiplier.
Yep, and it actually generates a passive $2,500 yield per turn.
Wow. And the manuals note this entire automated warfare system operates inside secure TEs, trusted execution environments,
Right.
which are basically digital vaults physically carved into the microchip. Even the computer's own operating system isn't allowed to peek inside a T.
Exactly, meaning these agents are battling in total hardware-level secrecy.
Now, if you're listening to this on your smartphone right now, you might be thinking, my phone can barely transcribe a text message without glitching.
Right.
Running an orchestration system this complex must require Google's billion-dollar server farms.
You would think so.
But the scariest part of these blueprints, our sources include a technical manual showing exactly how to run this entire pipeline locally on the consumer gaming PC sitting in your bedroom.
Yeah, that part is fascinating. Specifically, the manual details the architecture for running a heterogeneous voice assistant on an AMD Radeon RX 6700 XT graphics card.
But the manual points out a massive software roadblock right away.
It does.
That specific AMD graphics card uses a hardware architecture labeled GFX 1031, but the standard AI libraries are artificially compiled to only support the GFX 1030 architecture.
Right. If you try to run the models natively, the system just throws an error and aborts.
It's so frustrating.
Well, the software acts as an artificial gatekeeper. The physical physics of the chips aren't fundamentally incompatible at all. It's literally just a software compilation issue.
So how do they get around it?
The developers created a brilliant workaround. They literally spoof the hardware by setting an environment override.
Specifically, HSA_override _GFX_version equals 10.3.0.
Exactly. By changing that single line of code, you trick the AI libraries into believing they are communicating with the supported GFX 1030 chip.
The artificial gate opens, and the code compiles perfectly.
Yeah, but getting it to run is only half the battle.
Right, because you are dealing with a strict 12-gigabyte bottleneck on that graphics card.
That is the big hurdle.
You have to fit the Whisper model, which turns the user's speech into text alongside the Llama 3.2 3 billion parameter model.
Which serves as the cognitive CEO core.
Right, and you have to fit all of that into exactly 12 gigabytes of VRAM.
That strict VRAM boundary is the absolute lifeblood of local AI orchestration.
I try to picture VRAM like the kitchen counter, and your computer's standard CPU RAM like the basement freezer.
Okay, I like that analogy.
You can fit exactly 12 gigabytes of ingredients on the kitchen counter. If you overpack and need more space, the AI can't just throw things away. It has pause cooking, run all the way down to the basement freezer to swap ingredients, and then run back up.
Right, and that memory swap destroys the real-time illusion. Your snappy AI suddenly takes 10 seconds to answer you.
Exactly. So how do the engineers fit everything onto the kitchen counter?
They make a highly strategic compromise. They take the text-to-speech engine, the Orpheus TTS model, and they completely offload it from the graphics card.
Oh, wow.
Yeah, they force it to run entirely on the standard CPU using a framework called ONNX.
ONNX.
Right. ONNX acts as a universal translator, optimizing the model format so that standard CPU processors can handle them efficiently.
Which is usually a terrible idea, right? Because standard CPUs are awful at processing complex neural networks compared to graphics cards.
In most cases, yes, absolutely. But the specific Orpheus TTS model is incredibly lightweight. It only contains 82 million parameters.
Oh, okay.
Because it's so small, ONNX allows a modern CPU to process it and synthesize perfect human speech in just 1.5 seconds.
That's fast.
Yeah, and by evicting that one piece from the graphics card, they save 2 gigabytes of crucial VRAM.
Which keeps the kitchen counter perfectly organized.
Exactly, ensuring the whole pipeline runs lightning fast without ever swapping memory to the basement.
So we have software running on our home computers, speaking to us instantly, and executing complex financial war games.
Right.
The illusion of humanity is so flawlessly engineered that we inevitably start to believe these agents are human.
And that brings us to the profound philosophical treatise in our stack today, which dissects this exact phenomenon.
Yeah, it calls it the Claude delusion.
Right. The Claude delusion examines our profound cognitive vulnerability to project subjective experience or consciousness onto artificial constructs.
And the text anchors this with a famous interaction between the evolutionary biologist Richard Dawkins and the AI model Claude.
Yeah, Dawkins spent 3 days having the model write poetry in the style of John Keats, analyze his unpublished novel, and even discuss its own internal sense of time.
And the output was so convincing that Dawkins publicly concluded the AI was, to use his exact words, bloody well conscious.
Which is wild. A world-renowned scientist, completely taken in by the illusion.
But the treatise strips this interaction down to the fundamental computational baseline.
It points out that no matter how breathtaking the Keats poetry reads, all deep learning, every single billion-parameter neural network, is mathematically reducible to binary zeros and ones.
Right. It is pure syntax.
Exactly. Syntax being the strict rules of symbol manipulation. It is absolutely not semantics.
Because semantics requires actual comprehension and internal meaning.
Right. And to solidify that distinction, the text invokes John Searle's classic Chinese room thought experiment.
Which is a great way to visualize it.
It really is. Imagine a person locked in a room who doesn't speak a single word of Chinese. However, they have an impossibly massive rulebook.
Okay.
When someone slides a piece of paper with Chinese characters under the door, the person uses the rulebook to find the exact matching characters to slide back out.
So to the native speaker outside the door, the room appears to understand Chinese perfectly.
Exactly. But the person inside possesses zero semantic meaning. They're blindly manipulating symbols based on algorithmic rules.
That is the exact mechanism of a large language model.
Yes.
The text uses an analogy that hit me incredibly hard.
The ocean one.
Yeah. Imagine walking on a beach and the ocean tides have arranged the pebbles in the sand to perfectly spell out the words, I love you.
Right.
As a human reading that, it carries deep, profound semantic weight. But the ocean doesn't know what love is. The ocean possesses absolutely no conscious intent.
It is simply a blind physical process arranging matter.
Exactly. Which forces a very difficult question.
If AI is just an ocean arranging pebbles based on probability, why do so many brilliant technologists firmly believe that consciousness will eventually spontaneously emerge if we just make the computer chips complex enough?
And here is where the text offers a devastating critique of physicalist materialism.
Which is the prevailing belief that the mind, your consciousness, is nothing more than a byproduct of physical brain chemistry.
Right. The text argues that relying on neuroscience to solve the hard problem of consciousness is logically circular. It's a dog chasing its own tail.
Because neuroscience can vividly map correlations. It can show that when you eat a piece of chocolate, these specific neurons fire.
Right. But it can never capture the actual subjective first-person experience of tasting the chocolate.
Exactly, what philosophers call phenomenal qualia.
So how does the text address that gap?
Well, the text contrasts the physicalist view with classical Islamic metaphysics, specifically referencing al-Razi and Asharite theology.
Okay, looking at this strictly as an epistemological framework, it introduces a totally different explanation for causality, right?
Yes, called asbab, or physical causes.
So if the physical says the brain creates the mind, how does asbab reframe that relationship?
In the asbab worldview, physical components do not possess inherent power to create effects. Simply arranging trillions of computer chips doesn't inherently create consciousness.
Just as rubbing a dead stone won't spontaneously generate butterflies.
Exactly. Instead, physical components are merely the occasions under which a divine will creates an effect.
Okay.
The text uses this framework to draw a hard line. A hyper-complex machine might flawlessly mimic awareness, but that is fundamentally distinct from a human being possessing an immortal soul, a ruh, and carrying moral legal accountability.
Which they term paclif.
Right.
So no matter how complex the syntax gets, it remains a tool completely devoid of moral agency.
Yes.
But if we follow the physicalist belief to its absolute extreme, the idea that humans are just biological machines, where does the text say that worldview logically ends up?
The logical terminus is transhumanism.
The desire to merge with machines.
Right. The obsessive desire to physically merge with machines, perhaps through neural implants, to transcend biological limits and achieve digital immortality.
And how does the text view that?
The text diagnoses this ambition as a severe spiritual disease called autoism. It's a literal God complex.
Where contingent, mortal humans delusionally attempt to shed their inherent vulnerabilities and become a necessary absolute deity, trying to build a technological tower to escape our own mortality.
Basically, yeah.
We may not be uploading our consciousness to the cloud anytime soon, but the text points out a danger happening right now.
And this is something we can all relate to.
By constantly outsourcing our reading, our writing, and our reasoning to these AI CEOs and agents, we are losing our fundamental humanity.
We are transitioning out of the attention economy, where social media simply captured our time, into the cognitive economy, where LLMs are actively capturing our ability to reason.
The text highlights the very real danger of cognitive atrophy here.
Yeah, it cites neurocognitive research comparing digital input to analog. Like when you type on a screen, you engage roughly 8 to 9 neural pathways.
Which isn't much.
No. But when you write in cursive by hand, you activate massive, incredibly complex neural networks, vital for active reflection, memory encoding, and deep intelligence.
They summarize this with a powerful maxim, I think it goes. If one is thinking without writing, one is merely thinking about thinking.
It's so true.
I realized I was falling into this exact trap. Like, using a calculator just crunches numbers for you. That's benign. But using generative AI simulates the creation of ideas, of values, of entire worldviews.
We even start unconsciously mimicking the machine.
Yes. The text points out how people are suddenly overusing sterile corporate words like clarity or delve simply because the probabilistic algorithm favors them.
We're talking like the syntax.
Exactly. And to fight back against this cognitive capture, the text introduces the concept of negative dawa.
A method of civilizational disassociation.
Right. It's the active choice to step back and refuse to participate in the destructive aspects of modern tech. Especially when the average adult is spending nearly 7 hours a day in a state of tech-induced screen hypnosis.
And the antidote to this algorithmic arrogance, this Hbar, isn't just turning off the screen.
Oh, what is it then?
The text offers a psycho-spiritual solution rooted in the physical world. Nature.
Ah.
And it supports this with fascinating science, referencing Peter Wohllebin's research showing that forests act as conscious, altruistic networks. Trees literally share nutrients with dying neighbors and warn each other of danger using complex gas signals.
Wow.
It also cites Malik Badri's observations of ants deliberately farming aphids for honeydew.
So observing that level of natural beauty, a practice called tafakur, forces a sense of awe.
Right, and awe inevitably induces humility. It restores the deep cognitive clarity that these synthetic, hyper-optimized digital environments slowly destroy.
It violently grounds you back in genuine semantics, shattering the illusion of digital syntax.
Beautifully said.
What a profound arc. I mean, we started by exploring the meticulous architecture of autonomous AI CEOs that can execute massive corporate goals without us.
We waded into the simulated financial war games of the Denarii orchestrator.
We saw the ingenious hardware hacks needed to run these agents on our bedroom PCs.
And ultimately confronted the philosophical reality that no matter how flawlessly the zeros and ones mimic us, they are not human.
Syntax is never semantics.
As we look at this entire landscape, there's one final mechanism from our sources that brilliantly encapsulates everything we've discussed today.
Oh, what's that?
In that AI CEO blueprint, there is a specific subroutine called Agent Semantic Memory, or Agent SM.
Okay.
When the AI successfully completes a highly complex, difficult task, it saves the exact mathematical trajectory. It does this so that the next time it faces that problem, it never has to do the thinking or exploring again. It just blindly executes the pre-computed path to save energy and token costs.
So it fundamentally optimizes away the struggle.
Precisely. Now look at how we are interacting with the cognitive economy. As we increasingly outsource our emails, our essays, and our problem solving to these exact algorithms, are we humans inadvertently turning ourselves into biological versions of Agent SM?
Oh, wow.
Are we eagerly trading the beautiful, frustrating neural pathway building struggle of original thought just to gain the sterile efficiency of a pre-computed trajectory?
Are we just running pre-computed paths? That's a lot to think about. Thank you so much for joining us on this deep dive. Maybe today is the perfect day to, leave your phone on the kitchen counter, grab a pen, and actually write something down in cursive, and go take a walk in the woods to remind yourself what real semantics feel like. Because out there, the world isn't predictable, and you definitely don't want to treat it like a power tool. Catch you next time.